Next, let's look at the SR flip-flop. Your SR flip-flop is going to look similar to your SR latch. So it has two inputs, S and R, two outputs, Q and Q prime. So this is your flip-flop. And it also has the clock input, which is the third input to the SR flip-flop. It's going to function very similarly to the SR latch. So if you take the truth table, SR and Q plus, 0, 0, 0, 1, 1, 0, 1, 1. So for the SR latch, if S and R are 0, 0, you're just going to hold the previous value. If S is 0, R is 1, your next state will be a 0. If S is 1, R is 0, your next state will be a 1, and this is invalid or don't care. The only difference between the SR flip-flop and the SR latch is that you are going to sample the values of S and R at the rising edge of the clock signal or at the falling edge of the clock signal in the SR flip-flop. Remember, in the SR latch, as soon as S and R changes, your Q would probably change. But in the SR flip-flop, this change only happens at the rising edge or the falling edge of the clock, depending upon what the values of S and R are during that rising edge or the falling edge. So to better understand this, let's take some more examples. So here, again, you're asked to fill the timing diagram for a rising edge triggered SR flip-flop, and given that Q is at 0. So mark all the rising edges. So 1, 2, 3, 4. So initially Q is 0. So until the next rising edge, Q is 0. At this rising edge, S is 0 and R is 0. So we continue to hold the value of Q. Again, at this rising edge, S is 0, R is 0. Continue to hold the value of Q. At this rising edge, S is 0, R is 0. So we continue to hold the value of Q. And finally, at this rising edge, S is 0, R is 0. So continue to hold the value of Q. In fact, Q is always 0 in this case. Let's take one more example. Here you are given that repeat problem 4 with the assumption that the flip-flop is now falling edge triggered. So first mark the falling edges. So 1, 2, 3, 4. Initially Q is 0, so we continue to hold the value until the next falling edge. At the next falling edge, S is 1 and R is 0. Remember, that's the set operation. So after a slight delay, your Q goes to 1. At the next falling edge, S is 0, R is 0. So we continue to hold the value of Q. At the next falling edge, S is 0, R is 1. So after a slight delay, it's going to get reset. Therefore, Q goes to 0. At the next falling edge, S is 0, R is 0. So we continue to hold the value of Q. This is how a SR flip-flop works.